7 out of your textbook, we're given the function f of x is equal to 2x to the fourth. And again, we're asked to state the power and the constant of variation of the function. Then we're asked to graph it. Then we're supposed to analyze it. And then in the manner that's done in example number 2. So I'm going to look at my book in example number 2, which is on page 189. Oh, it wants like the domain and range and where it's increasing, where it's decreasing, are there any, is there any symmetries, extrema, so on and so forth, right? And behaviors. So my constant of variation is what? 2. Now what do we know 2 is going to do? Graphically speaking. It's going to stretch it vertically. Our power, which is the degree, because they're monomials, right? If it was a polynomial, we'd choose the highest power, and that would be the degree of the function. But this is only one term, it's a monomial, so whatever the degree of the monomial is, that's the, or whatever the power of the monomial is, that's the degree of the function, right? Well, that's 4. Now, what you guys may not realize is, or maybe you should realize, x raised to an odd power always kind of looks like this. It comes in here, does some stuff in the middle, and goes out. Comes in from the bottom, goes out the top. Can you guys see the green on the screen or no? Green's not real good, is it? So we'll use orange. Now, an even function, so if I say y equals x to an odd power, here if I say y equals x to an even power, always reverses itself. So I'm always going to come in from the top, and it may do all kinds of crazy stuff here, but it'll go right back out the top. Which is this one. It's a 4th degree. Four is even. Which one will it look like? This one. Now we could shift this left or right, we could shift it up or down, and we can even add some, if this was a polynomial, the different terms on the inside determine the behavior. But it's going to come in from the top and go out through the top every single time. So now we're going to graph it. What? Yes, we're going to graph it. Say it isn't so. No, it's true. We're going to graph the function. Mr. Adams, are you serious? Yes, I'm very serious. Are you talking to yourself right now? Of course I am. Is there a student in my classroom waiting for me to crack my voice? Yes, of course there is. What else do you guys try to catch me doing? So, now as I graph this, so I'm going to enter in 2x raised to the 4th, and then I'm going to choose graph. And if I slide down a little bit, there's my graph, just like Mr. Adams said. It looks like a parabola, but because it's a 4th degree polynomial, it takes a little longer to grow. So I'll get something like this. Right, what's the domain? What's the domain? Can somebody tell me the domain? All real numbers? Yep. Very good. What's the range? Remember, the range are the possible y values. What do you think is the lowest y value? 0. If I plug 0 into the function, I'll get 0 to the 4th power, which is 0. 0 times 2 is 0. What if I plug in negative 1? Negative 1 times negative 1 is positive 1, right? Times another negative 1 is a negative 1, times another negative 1 is a positive 1, right? So it's always going to be a positive value. So what's the lowest y value I can have? What's the lowest y value I could have? 0. What's the greatest y value I could have? Infinity. So my range goes from 0 to infinity, right? All right. Do you guys see any symmetries? Let me rephrase that question.
Yep.
Do you guys see any symmetries?
Yes.
Yes. What do you see?
The symmetry.
Symmetry about what?
Y.
Very good. When is our function increasing? Think in terms of x. When is our function increasing? From what point to what point is it increasing? Technically, I should draw the arrow this way. So, when x is greater than or equal to 0, right? Or we could just say greater than 0. When is it decreasing? And remember, we got to read this thing left to right. When x is less than 0. Now, how can I tell when something's increasing or decreasing? When the slope is positive. When is the slope positive? Well, you can't see it, but right here, as soon as we move away from 0, we have a positive slope. It becomes more positive, more positive, more positive, more positive. So that means the function's increasing. That means we have a rise over a run. When is it decreasing? Well, when I start here, I have to go down over, down over, down over, down over. It's a negative slope. Well, that occurs when x is greater than 0 for the increasing part and x is less than 0 for the decreasing part. What else? You could write it this way too. You could say like 0 to infinity and negative infinity to 0 is another way to say that. Is it an odd or even function? It's an even function. Anything that's symmetrical about the y-axis is an even function. And we know it's even because it's even. I mean, it's literally even, right? Even function. What else do we know about this function? Does it have a local min or max?
Local min.
Yep, it has a local min right here. When x equals 0, y equals 0. Are there any asymptotes?
No.
No. What about the end behavior? What does this look like it's approaching as I go towards x, towards infinity, right? As I go this way towards on my x-axis towards infinity, what does my y value approach? Infinity. Now, if I take the limit of f of x as x approaches negative infinity, in other words, I'm going to go this way towards negative infinity. I follow the curve this way. What does my y value approach? Positive infinity again. This is always going to occur when we have a monomial with x raised to the even power. What would it be if it was an odd power? Well, as we take the limit to the left, we would approach negative infinity as we approach to the right. Now that's saying untransformed. If I put a negative sign in front of the 2, what would happen to my graph? It would flip over the x-axis, right? We know that, right? It would take all my y values and make them negative y values. So you guys are almost there, right? You pretty much know what you're doing, right? Okay. Any other questions? That's all they wanted us to do is like, oh, is it bounded from above or bounded from below? Bounded from below. Good.